Good morning. Many of you have joined. I hope I am audible and my screen is visible. Okay, good morning, Chetana. Thank you. Okay, Chirag. Yeah, I see you guys here. So, guys, let's wait for 3 minutes or so. Let's give little time for others to join, and I will start in a while, in 2 3 minutes. Okay, good morning, guys. Can we wait for 1 or 2 minutes more? Okay, we can start. Let me just go through the chat. Chetna says no voice. Now am I audible, Chetna? Chirag, yeah, sorry, I saw your message now. You wanted to speak something, and I see message from Sachin. He has explored Titanic dataset, and he says Unidecode is a library used. So what is that library, right, Sachin? Yeah, we'll talk about it. Anybody else has anything to talk? Yes, Chirag, you have any specific thing to speak? I can unmute you, or I will unmute everyone. Just a moment. Yeah, so I have unmuted everyone. You guys can unmute yourself and speak if you want to.
Ganesh Chirag here.
Yes, yes, Chirag.
Yesterday, in the end, what we were talking, we could not finish because the
Yes.
voice again,
Uh,
yeah,
yeah, I apologize for that. In fact, this
that's okay.
connection was
Uh,
reset.
but while you were not there, we were able to talk to each other, and
Okay.
we came up with the idea that let's make a common WhatsApp group in which we can help each other solve problem like throughout the week.
Okay. Okay, fine. We will see if this can be done. And I have who will take that lead?
I can do that. I can create a group and send the link to you, and you can share it to everyone. So they can
Uh,
just click on the link in their mobile phone and they can join that.
okay, fine. So let's decide it. We will talk one on one, and if it is feasible, then we will do. But that group should be only related to our only the chat related to our training. There should
Yeah,
not be any other.
definitely.
Yeah. So maybe if that is the case, then we can do that. Perfect.
Okay.
So and about Sachin, Sachin, yeah, Sachin has the question about Unidecode, and it's really nice to see you guys doing something and come up with the questions. So where did you see Sachin, by the way?
Am I unmuted? Yeah. Ganesh, I saw that on Kaggle. It was on Kaggle only. I was
Okay.
reading through the wiki of the kernels and I just checked it and I found that Unidecode has been used there.
Hmm.
And I could not read it completely though, but I saw and I thought I should have a discussion about that.
Yes,
It
yes,
was just
sure.
last night, so I could not explore a lot about it.
Yeah. See, basically, how texts are encoded. You might have heard about ASCII. So, it's a universal standard for
ASCII languages, right?
yeah. This way we can read and we understand. But there are many symbols, many special symbols, or many characters, right? So, which is not understandable by the user. So those characters, for example, some Chinese letter or the French letters, right? So those are not the English letters, and for that we have to do some kind of decoding, and such letters are encoded and decoded to make it compatible or to make it readable by the users, right? This is a general understanding, a general technique across many softwares or computer systems communication. This works, right? This is nothing to do with specific to Python or specific to ML, but that kind of technique where sometimes those special symbols like Chinese words or the Japanese words or the or Hindi words so can be even make available to use in the computers, and computers can't understand those, right? So it has to be encoded and decoded to make it understandable. So those character stream if we receive, so there is a need of decoding, and probably you might have seen that package Unidecode. So Unidecode is Unicode functionality, so it's not there. Maybe it's something we need to install, right? So that functionality we can use to decode your library, and we can use it. Okay, so this is straightforward, pretty simple. So a lot of time you might have seen some string. Let me unmute if you're not speaking. Yeah. Okay, so you might have seen, some output like this in the Unicode format, right? And I don't know what to type, but we can just do anything, right? Or like this, some U and some characters and some strings like this. So it is difficult to, really understand what does that mean, and it can show us in something this format. Okay. So for such strings, so we have to understand how this Unicode can be used or decoded and to use further. So maybe you can explore a little bit more on your own, and you will find some interesting stuff with that. If at all you get such characters, if at all we deal with such data going forward, we have to use that. So usually we don't need it. Okay, so in normal cases we have many or in fact these things are kind of done implicitly, but if you are dealing with some special symbols, so that time Japanese or Chinese words, you have to use this library. I used once long ago. Yeah, so is that fine for now? We can continue with our topic now, topic for the day. Anybody else has any other question, guys? How many of you could try? Okay, Jim, thank you. How many of you could try Titanic dataset? Guys, this is really important. So Titanic dataset we haven't done because of couple of reasons. One, I wanted you guys to do something on your own, and maybe I can spend 10 minutes to just get that data, and maybe we can just explore if you guys want. But how about you guys doing it? Or have you done it? Or you guys want me to quickly show you some of the real data set kind of data we can use, and we can just see how many males and females were survived, and how many were could not survive, or how to what kind of aggregation function we can try to segregate those people who belongs to particular class, and their average age, and what is the population who survived, what is the age group, which age group people survived more, who survived more, whether male survived more or female survived more. So this kind of data are the information we can extract from this data set using pandas. So I hope you guys understand by now the pandas, how to use it. But these are some of the things I wanted you guys to do. So is there a need to do that, or shall I proceed with the linear regression? Can somebody type here and quickly let me know? Okay, Sunil, we will do this sometime later. Otherwise, many of the people are saying that let's proceed with linear, and I'm really excited. Let's write our first model today in the machine learning using linear regression. Simple linear regression we will do today, and I will come to this data set or some other data set to retrieve some of these operations. And in fact, I have given one assignment yesterday. If you could do those questions, so whatever discussion we have done just now about Titanic dataset, so those things are really possible for you guys to do on your own. Okay, so that assignment is really important. I don't know if you guys got a chance to do it yesterday, but if not, during weekdays you can find some time. Please spend some time and do. Yes, Sunil, I will increase the font, and then I will start with the simple linear regression. Okay, so what is simple linear regression, or what is machine learning, is more about predicting some data or some information based on your historical data. Okay, For example, I will take one simple example how this prediction works generally, in general, in day-to-day life. Let's say, uh, I'll take a, let's say, a waiter. Okay, so waiter is serving meals, and let's say there is one meal, two meal, three meals, and he's also getting tip for each meal he served, right? So let's say any numbers, we can just take that, maybe some people give this tip like this or like this. So by looking at this, there are two things here, right? One is just number of meal number, and there is tip. How about if I give you billed amount? Right, now it's easy for us to understand, okay, if a bill amount was higher and probably tip was higher or something like that, like we can get some clue out of this. And suppose if we don't have this bill amount, and I want to predict what could be the tip we might get, right? So in this scenario, this is the only one variable we have, right? And with that only one variable, we have to predict what could be the next tip the waiter might receive, right? Correct. So with this a single variable, it is really difficult, but still, if we want only one variable and there's no further information, so what best we can do to predict? So based on our earlier understanding, most likely we can take average of this tip, and we can just predict that, okay, so somewhere in between this range, the average value could be the tip what he can receive, possibly, right? And obviously the average, somebody pays this way, 200, and 10 and 5, so average still says that there's a possibility of getting 50 or 80, 80 rupees tip, as such, correct? So this kind of prediction is possible just because using single variable, right? And that is the dependent variable, and that there is no independent variable as such. So I hope you guys are aware now what is independent and what is dependent variable. Okay, so this is one, this is a scenario where we can think about how to deal, how to predict something based on a single variable. And if we see this, I have this print. Oh, sorry. Yeah, so how one can predict is, just we can just say that, okay, what is the amount he received? Let's say for first meal, little bit less amount, for second it is more, or these are some of the tip amount, let's say, waiter has received. So so what is the best fit line, or best, the best, predicted line out of this? We cannot, do see any relationship, because we don't have any other variable to really provide some insight about it. So we can just keep a mean of it. So this is a mean of the values what we have received, and we can just predict this way. And this is the error we have already talked about. So somebody says that above this line, this, yeah, above this line, there's a, above mean, if somebody gives, there is a positive error. Sorry. And below this, there's a negative error, right? So there's a very limited information for that matter to talk about this. And since we have only one, okay, since we have only one, the best fit could be the mean line, and the values around mean is the possibility or the prediction one can do for the future tip amount. And if there is any variability, sorry guys, Yeah, I'm back. So if there is any variability, that variability can be only explained by the actual tip amount, what the user might receive. Okay, so that was about without any dependent variable. Now let me just talk a little bit about something. If we have some dependent variable and independent variable, or multiple dependent and independent variables for that matter. Okay, so we can do that. And we have already seen yesterday that there is a linear relationship between between the data. And let me just pick something here. I have some student. I'll take one small example first, and then we will go with little more bigger example. So let me just type this desktop and just copy this path from here. What is the type? CSV, right? Import pandas as PD. I will just import basic libraries as we need. Mostly we should import all this at once. Import matplotlib dot pyplot as plt, and we might need import cborn. We don't need in this case at least, but just to keep it as SNS. Okay, I've just imported all these libraries, and now I just want to get this data equal to what is that? PD read CSV. Oops, sorry, this one. And what is the file name? Let's say salary data. I'll open this and I will just explain a little bit here about this, and we will see how we can do write our model, the first model with this data. And then I will go to some real data. Maybe we can go to the Boston housing data for today. So you can see there are only a few, only two columns here, and around rows are, I don't know how many rows are there. Let me just check how many rows are there. So around 30, right? 30 students, 30 employees. So let's see that there is an experience and there is a salary. Okay. So maybe I can see this bigger. So experience, 1.1 and 39,000, or maybe it's in dollar. And then 1.3 salary is increasing, 1.5 now less than 1.3, so and so on, right? So the bottom line here is, so we have salaries of the employees, around 30 employees. So who have this is kind of a existing existing employees, and in our organization, suppose these are the employees who withdraw this kind of salary in the company. And now we want to hire a new person, right? New person, and we want to predict what could be the salary based on his or her experience and number of years of experience, right? So there is a relationship, and we have to predict that relation. We have to literally, we have to in fact make system, or create a model which will learn that relationship, and then we can think about predicting for any new employee who carries some experience. I'm talking only one experience here, but in reality there could be many, right? Maybe his technology, his domain, lot many things comes, right? So simple linear regression, where we will talk only about uh, one independent variable and one dependent variable. That linear relationship we want to figure out, we want to find, and that is our goal. Okay. So let me just write down here, the salary is the one which is which is this variable. Salary is dependent, independent. Yes, dependent variable. And let's say there are two things we talked about: B0 plus B1 into experience. experience, right? I'll just make it yes capital. Yeah. So this is a formula, right? This is how we have understood yesterday. We have seen that this b1 is a slope. I will probably draw one diagram which can explain a little bit more. And this is a constant value, which is epsilon, which is kind of the error, or which is kind of a minimum value or minimum salary. One employee who has zero experience, right? Obviously we can look at this, and even if there is zero experience, this much is the basic salary one will have. Okay, so let me just see this example here. Okay, let me just draw this diagram. So I'm not good in painting, but I'm just trying to use this. So suppose now I have salary and years of experience. So I'll just write down here experience, and here there is a salary. Okay, so now let me just see that there is a person who is having, let's say this is 1 and 2 and 3 and so on. On this line, we see the number of years of experience people have. And one, if I want to draw this particular point, a data point, so 1.5, 1.1 year, 1.3 year. So these are some of the people who is carrying, holding this kind of salary, right? Maybe I will just start with, let's say 10K salary, and then 20, 30, 40, 50, and so on, right? So suppose this is either monthly Indian salary or in dollar, that is fine. Okay, so the first data point I can point, he do the here, the second could be here, right? Third could be here. And now this, how I'm drawing these points is looking at the data what we have, right? I may not be doing it perfectly correct way, but more or less our data which is there in this particular file looks something like this. Okay, so 1.1, a person is having this kind of, maybe this is 30, let's say, right? Maybe 30,000 or something here, right? Or maybe a little bit more, right? Maybe we can start from 10 here, 30 here, 50 here, and so on. So this is the linearity we can probably call. And let me just do this small thing here. I just want to draw the line which represents the linear relationship between all these data points. So this is pretty obvious that as experience grows, the salary is growing. And this is we are not saying that, this is the data which talks about this. Okay, and we understand that there are few points. Now this line, whatever line we have drawn here, is basically the prediction we are making. Okay, so just ignore this line. Yeah, I can just do this. So this is the predictions. I'm we can think about this kind of a predictions are make we are trying to make from this data. Okay, now let me just show you a couple of things which is very important for us to understand. So what is b0 value in whole this diagram? Anybody can guess? Anybody? Chirag says near 10K. Yes, right, Chirag, near 10K on the salary line, right? And this is the point which is actually a B0. Okay, and what is B1? B1 is a slope. This is what we have discussed. So slope means on every year of experience, if your experience is growing, right, yearly, let's say we talk about every year, 1 year. So we want to understand, so for 1 year of experience, so I just will draw here with the gray color, and we want to see how this looks like, right? The slope is getting on this particular line. Okay, we talked yesterday about that is a slope variable, and I can just look at this and try to figure out what slope means, right? So this is the slope on the line on the predictions, and this slope is what we talked about, right? Sachin is saying there is no voice. Is it true for others? No voice. Oops. Strange. I'm unmuted already. So how come my voice is not visible? Voice is there. Voice is there. I can hear. So Chetana says audible. Vivek says he can hear. So let me rejoin. Mayank says audible. Sachin, you please try once again. Shekhar says voice is there. It's okay for everyone. I can hear. No voice. Okay, it was only for Sachin then. Okay. So, okay, great guys. Okay, thanks for the quick response. So Mayank also says, Dikesh says, perfect. So I was talking about this is the slope what we talked yesterday, but just by looking at this, what do we understand, right? The slope is actually nothing. It won't give anything as such unless we make it the clear understanding about what it is. Now let me just draw a line here, and we look at this data on the salary axis. Okay, and this is the range of salary which varies, right? This is the value, or let's say it is let's say 7k. Okay, 7k or something like that. Okay, so 7k salary is the increase in the salary. If you see there is, oops, what is this? Yeah, if you see there is a increase in the, okay, leave it. So 7k is the slope, or is the proportion by which the salary grows if experience grows. So there is no direct proportion, but with this kind of fraction, so the salary grows. There is a relation as experience grows, but it's not that if 1 year experience grows 1000 it increases. No, what that value is, that can be drawn using this slope. In this diagram, zero experience salary is 10k. That is a question. Yes. So in this diagram, it is little more than 10k. In fact, right? Because our line is touching a little above to 10k. 10k is this. Okay, but our line is touching here, so it is little more than 10k, maybe 12k or so. But you are right. You got the point. I think. So here B0 is this value. Okay, so that is the what we saw yesterday. That is the epsilon we said, or whatever you call this, is the constant value, and the 7k is b1. That is the slope, or the intercept we have already talked yesterday as well. Right, I hope this is clear now. And we also speak about mean squared error, and that error also we talked about how your actual predicted values and your data points have this errors, and those errors can be squared and check the accuracy of your model. Okay, Chetana is asking about one more time, and please explain B1. Chetana is asking. Anybody else have question on this? This is a basic one and important to understand. It's a very basic formula we are talking about, and here the relationship between these two variables we are trying to get, and we are trying to understand B0 and B1. These are the variables in this formula. So where the relationship between this independent and dependent variable is what is our goal to predict, to get understanding about. And there is a relationship, there is a linear relationship, meaning as experience grows, by b1 times your salary grows. So if your experience grows by 1 year, your salary is not growing by 1000, right? So if the salary unit is 1000 and here employee unit is year, so there is no this kind of directly proportion, but there is a direct proportion. It grows with by b1, and b1 is the slope we have talked about. And let's say this is 1 year. 1 year, I just write here. Okay, suppose this is 1 year window we talk about, and if this 1 year can be marked on this prediction line, so that can be marked with this kind of slope, right? We talked about this yesterday, that b1 is a slope, and by looking at this slope we can just check on the salary axis that there is some amount which grows by every 1 year grow in the experience. and surely this is a linear line we have drawn, so that kind of relationship we can predict. And understand this pink line is a predictions we are talking about. So this red spot is a b0 value. This is a constant in this equation, and even if there is zero experience, a fresh graduate uh, who is joining our company, and he will get b0 salary. That is the minimum salary company has. And if company also pays zero salary, then this line would have started from this point. Okay, let's not get confused with that. So that is not a mandatory to see the relationship between these two, but that is how this b1 plays important role to predict or to draw some kind of conclusion that this is a relationship between these two variables. Okay, this is again theory. Yesterday we spoke a lot about this theoretical understanding. Let me go and do something here, the real kind of building some model here and playing with this kind of data here. Now we got a data, and we have printed these two variables. So how to get your variable, dependent variable and independent variable? Yes, how to get your x and y? X equal to, yes, data experience. Rakesh is saying experience. Yeah, experience. So x is equal to experience, so we can just get this way. Or if there are many variables, I can also try to get this our learnings. I hope you guys recall all these things. We can also go with the iloc functionality, and we can just in this case, your year of experience is the first, so the last column is something I don't want. X are dependent variables, sorry, independent variables. So salary is the only dependent variable, so only that can be removed by using this slicing mechanism, just by removing the last column, and we can also get those values, right? I hope this syntax also is fine. If there are multiple such rows, so such columns, you would have just removed salary, and rest of the data set becomes your x, that is independent set of data, right? Independent variables. So here this is a simple one, so we can just do years, and we can just pick that one. But if there are 2, 3, 4, it is not a good idea to just write here some other such all these things, right? Instead we could have done on the by this way, where we know that there is only one dependent variable, and usually that is the case mostly. So only one dependent variable, because we want to predict salary, and now it depends on other parameters, like we talked about rainfall and crop yield and humidity and temperature. So crop yield is the only column which is the dependent variable, and rest all is independent. So in that case, I just want to get that dependent variable by removing the crop yield from this particular data set. So that is possible. So that can be done using the slicing, as well as whatever the techniques we have already been looking at this pandas data frame for that. Okay, now x is we got x. Now let me just get y also. Y data, I can just get this into let's say column. I mean, there is only one, so I can just do this also, right? I hope you guys follow this syntax. Y dot head, I'm just checking what is there. Oops, there is something wrong. Data dot iloc colon 1, and this value. But okay. So this is the NumPy format, right? So it is giving you, because I'm getting the values, right? So that is the reason. But here, since we have a single variable, we can also do this here also. And if it is having more, then we can surely go for this iloc and get the position and get these values in the NumPy also. Okay, that is fine. Y dot head and we got this salaries here. So just I have splitted my whole data, and that data is now, let me just open this Excel also. So probably that will help you to relate or look at this. Okay, all right. So this is how we got X and Y. X is independent variable, and Y. See, I use X as a capital, and Y, this is, there is no rule as such, but just dependent variables are one and the independent are many, so I use X, dependent variable, and dependent variable here is salary, and independent variable here is years of experience, okay. So this is just for you guys to have it here. Okay, so are we good with this? Now let me understand. This is a basic understanding about your data. We got all salaries as a dependent variable, and that is the target also. We want to make a model where once I find the relationship, our model should predict that salary for any new data which is coming in, right? So we have talked about splitting the data, and why we split. I hope you guys can understand. You guys understand it. No, I don't want to do this. Okay, we got it. So we have seen that some data can be splitted here. So let's say I have 30 rows. So I just want to use some at least 20 rows to create a model, to train the model, and rest I will just use this for the testing purpose later on. Okay, so let me just use one more library, which is important library for machine learning, that is called scikit-learn, right? This is the first time we are trying here. Import from scikit-learn, and there are many libraries inside this scikit-learn as well, right? If you just press tab, you will see many libraries. There's a cross validation which I can use here, or you may go with some other library. I think we can use this. um, there is linear, is there anything, linear model. Okay, so linear model import, there's a train test split. So we wanted to split, do you remember, right? Yesterday we discussed about this train test split. So I just wanted to do this. So what is this error? We cannot import, it says. Anybody recall how to use this train test split? No, that's not in the linear model then, right? It is, I think, model selection. Yeah. So anybody says something, just a moment. I see a message. Okay, we are using it for first time. Okay, Shekhar, no problem. So I'll come the linear model. Linear model is another library package, and inside that we have linear regression or logistic regressions, or many libraries there. So I was I got that. But anyway, so model selection is the library inside sklearn. So sklearn is the base, the parent of everything. A lot of things are there. It is again very powerful. A lot many things have been developed, and it is readily available for us. So we really don't have to do so much. Just I think the cross validation also does this. Let me just verify, because I somehow recall this from sklearn dot cross validation import train test. So the same thing is provided, this couple of functions. Yeah, these functions are provided in two locations, in fact. Okay, so that's what, because I use this and I recall somehow that there is a train test split available here. but I think model selection is the good one to use. Both are same, exactly same, by the way, right? Let's not get confused. So yeah, this is the function which is already provided. Okay, now let me just check the help page of train test split. How to do that? I can simply write here, and I'll press shift tab, and I can see what is this it talks about. Right now it talks about arrays. Okay, arrays means it is a numpy array, and we can just give this that split arrays or matrices into random train and test subsets. Okay, it is very important that we are now dividing our data. What we talked yesterday, I just want to divide this whole data into two parts. There is only one variable, so this much I want to make one part of it. So let me just do here, here on which I want to make the testing on this data, and sorry, training data. I want to use this data to train the model. Okay, where I'm telling the model that, okay, these are the experiences and these are the salaries. And model has to figure out the relationship what is there, so that I can test the same model using this data here, right? And I will check that if whether this model is doing what is expected or not, and I can just check if that gives me the right output or not, right, using the second part of this. Right here, this I will say whole thing is uh, test dataset. Okay, and we can say that this whole thing is a train dataset. Train dataset. Okay, I hope this is good. You guys are not lost, right? This is simple one. So why we do all these things? Okay, so let me just tell you that if a person is joining with 17 years of experience, I'm a startup, I don't know what salary to give, right? But not only yeah, Veena wondered what is the key. I used Shift Tab and for what? Probably she missed that part. So see, if I want to get the help of any function, we have been using this in many classes. Shift Tab gives you the help of that particular functionality. So this is a function. I just press Shift Tab and I can just see the help page for that particular function. Okay, so yeah, while using, you'll get this hands-on. So let me just come back to the to this. Suppose a new person joining having 17 years of experience, so my company doesn't know what salary we should give, but it should be in line with the whole employees, right? I cannot differentiate the employees, but my model will predict what salary I should provide. But there is not the only uh, the criteria or factor here. There are many things, but as part of linear model, so if 17 is the years of experience, so what could be the salary? If that is my question, so our model should give this output, right? And how model understands about our company is, this is the trained data set I'm talking about, right? So I'm training the model, so part of it I'm using this data, the bigger chunk of this data, and I'm telling that these are the experiences and these are the salaries. So what is the relationship that model has to learn from this data, right? And we are now creating, so we got this test split train test split function, where we can just find out our train data set, our test data set. Okay, and then we can get a train data set for the other variable, that is dependent variable, and test data set. So these are the four parameters this function returns, and it, of course, it expects the data set here, right? So the data set is X, it expects, that is the independent variables, and then Y, that is the dependent variables. These are two important parameters we have to pass. Okay, and we have to also pass that what is the test size we want to use. Okay, so we can just give test size as, let's say, 1/3 of the data I want to use for testing purpose. Okay, and there is a random state. I will come to this in a while. Let's try to just see this quickly. Yeah, I just changed a font little bit to accommodate everything in a single screen. Okay, now we will see how this train underscore x dot head it looks like. Okay, this looks like this. We got this training data, so just ignore these indexes, but our training data is like this: 10, 1.1, 5, and so on. There are many rows, by the way, and test data is this much, right? There are only 5 rows, so 1/3 of 30 is why one. Okay, only 5 rows printed here, but there are more actually, right? Yeah, so 1 2 3 4 5 6 7 8 9 10. 1/3 of 30 is 10, right? So I printed 20, but still it would print 10 only because there are only 10 records we have. So is this clear till now? This is the basic steps which will be useful for many uh, many programs or many models. We are doing this pre-processing stuff, and now let me just write down text dot shape, and I'll see here this is the 20, and let me just also type here train y, and I'll see that that is also 20. Okay, and maybe I'll just do this test x, and I'll see that there are only 10 rows for that. Okay, so there are questions. Last line, please. Chetna is asking. Then Rishu asking random state. I said random state. I will explain. Just more, hold on for a moment. Now, what is the use of this one? Yeah, random state, right? So Rishu, just hold on. I will come to that point. What is random state and why we need to use that? But otherwise, is this clear? Because I am now splitting this data into two parts, that is train x and train y, and test x and test y. Okay, we got this data splitted, and we got into our into this two sets. Okay, great. I see clear from Mayank and Ishu, and I hope it is good for others also to go forward. Perfect, guys. So this is something, the basic things, how to split, how to use your data into splitting this into two parts, where we can use this for our model to be trained, and then we can use this for further feeding this to the model itself, right? So I will come to this in a while about random state. This is just a random number which is used to pick the data, okay, by meaning that after every 5 rows, so there will be one, how many, yeah, there will be five, every in some interval it will pick 5 rows, and then it will go and pick another 5 rows. So that is what it says. If I change it, there will be little change. I'll come to that. Okay, Chetna question, and she's saying that test x is a variable which hold value from the train test split x, right? Okay, no, see, so not only train x, train y, test y, see, all these variables holds values from x. X is a original data set. So I will do a little bit here. I'll take your 2 minutes, guys, but I just thought of doing this here. Okay, quickly I will do this here. Just I will explain you why, because here little bit some more stuff I can show you here. I can just do this x and y, and then I will use this train test split, and I use this here. Okay, cool. So let's say I have this now. Okay, I just give some name here. So let me just run this, and I see what is happening here. Okay, here there is object explorer. Probably we can go and look for, oh, where is that? Um, console. There is object explorer. You guys understand? Remember this? Where to see those? Let's show. Uh, so there are some windows we could explore directly. Okay, I'll find out in the break time. So there is a visually we can just see those objects here on the right side of this uh, spider. Console menu, debug menu. Yeah, so where is that console menu? Yeah, consoles, open IPython. Okay, that is IPython is there. Okay, maybe I lost here. View panes, docket. Okay, no problem. Let's not spend a lot of time there. One last try. View panes. Where is that pane? I don't know. Somehow this panes is now not activated. I'm not able to see that. But I was having this. I don't know when I did remove that. But console, restart kernel, connect to the existing kernel. No problem. Okay, no problem. I'll find out this later on. So the only point here is both the four objects we could see the values, but here also we can do the same thing using head function of this data points data, right? So we can see that now head is having. So let me open this Excel. Now this data is train X. Okay, let me just do this. This is a train X and this is train Y, and this is the train Y. So train X will have all these data points, right? So I'll just show you here again. Train X dot no, just train X. I can just print it. See, we can see this 2 10 32 up to 8.5 8 point, no, all these data is there, right? Here it is sequential, but here there is no sequence as such. So that's the reason it is coming any in the random way. And these are the points here. How many total? 24 counts, right? And this is also 24 if you see here. Okay, so that data is now almost 66% of your whole data set. No, not 66%. In fact, this is 33%, right? So 33% means this much is our data. So let me just change this a little bit here. Yeah. So our actual split is happening with 30%. So this 30% is the train X, and sorry, this 66% is a train X, and uh, the salary, that is dependent variable, and that is 66% that is stored in train Y. And now this is a test data. So we have test X also, and we have test Y as well, right? This we will use for testing purpose in a while. So we have just splitted our whole data set into these four parts. Okay, that's it. So this is what we are doing by by doing this train test split function. Okay, and random state is just a variable which is or the argument which we provide to pick those values randomly, and that is important to do so. The reason is suppose I'm talking about temperature for 30 years. So and if my sample data I'm getting for testing purpose is sequentially for first 5 or 10 rows, so that is not a good idea, right? So I should pick those samples from across the different years probably, right? So maybe a couple of records from first year, two records from third year and seventh year, and maybe 20th year, and so on, right? So I cannot just go in the data to get only few years of starting of this data, right? And suppose there is a 50 years data, so I just cannot go and pick the 70s temperature as a sample to test this model. So what I want to do is I want to set some random state, so that, and every period or specific interval, so it will pick one row and then move on to skip many rows, and then it will jump onto another one row, right? For that matter, if I give 5 or 2, so it will just pick your data set, because the reason is we want to only pick 33% of our data for a test purpose. So that test data we can pick only 2 records at a time, and then move on to the next block on which we can pick that data. Okay, so this is about random state. So maybe I'll explain a little bit more once I do with some other data. That time you will get it little more clarity about this random state as well. Any question? Okay, so you guys want a break? Maybe I can break for 5-10 minutes, and then we can resume. Yeah, so it is 9:06 now for me, and then we will go, and yeah, we will be back by 9:16. Exact 10 minutes, guys. Let's not waste time, because mostly I have to leave 15 minutes early today. So by 10:45 I have to drop the call. I have a hard stop, and I got to go to some meeting here. So we will be back by exact 10 minutes. 9:16. Uh, I'm back, guys. So I see a message from Chirag. So just 1 minute, Chirag. I will explain about random state once again. No, not from Chirag. Who is asking? Yeah, Mayank is asking about random state. Okay. Yeah, probably this could be the question for other people also. Uh, am I audible? Okay. Okay, so this is 9:16, so I start now. So there was a question Mayank was asking about the random state, and probably other people also have a question, the same question. So there might be the same question. So let me explain a bit here about random state. So now first thing is train, test, split. So what this function is, it is all about you know picking some rows and putting into train X and train Y. So I think this is clear, right? So we want to get our data, a whole data, and pick some of the rows into train X and some of the rows into train Y. Okay, I think this is I know this is important for you to understand that some of the data into train X and some of the data into test X. Okay, if this is clear, right, then rest of the things are very easy to understand. I repeat again, I want to pick some data into train X and some data into test X, because I want to make some test after this, and I want to also train my model using some data. So definitely it is not a good idea to just sequentially pick these elements and put into train X. So understand, this is not the way ideally one should do, right? Just assume that this is the temperature for 30 years. So just picking this temperature for first 20 years and testing that model, training by giving first 20 years and testing that model in last 10 years. So this won't be give you a right predictions, isn't it? So it is very important to pick the samples from different intervals, right? And from anywhere. By giving random state equal to, let's say, 2, we will give 2, let's say, right? So random state 2 means you pick randomly this 2 rows from anywhere, the data from this data, and then put into the train. Let's say I pick this 2, I put into train. I pick this 2, I put into test. I pick this 2 maybe, and I put into train again. I pick some other 2 here, I put into train, and some other 2 here and put into, let's say, test, and so on. So this is just about the number of records I want to pick randomly from anywhere of the data set and put into train and test data sets. Is this clear, guys? Yes, okay, Mayank, it is clear for you now. How about anybody else is having same question? Shekhar is saying if we give some same random state split data, the result will be same. Yes, Shekhar, you are right. So if you give random state 3 and you do the same thing in your system, and if I'm doing on my system with the same data, so randomly, no, it will randomly pick. So not necessarily, sorry, it will randomly pick, but it will pick only 2 records at a time. And if it is 3, so 3 records it will pick at a time. Yeah, it is picking randomly, guys. Chirag, it will pick randomly, and it will pick those many rows at a time. So that is what it talks about. It is not about it won't get the same result if we do this on on 2 systems. So randomly it will pick, and it will pick those many records in one go, and it will put into the test and train. Is it clear, Chirag? Okay, great. And Rishu, any idea ideal value for random state? No, there is no any such ideal value. So it is generally, let's say 5, 6 or 10 it should be good. We don't have to really think so much about this. Assume that there are billions of records, so even 100 should be good. And if you have only 30 records, no point in making a random state as 100. So it is something you guys can decide on the go. You guys can decide based on your data. Okay, so the concept is clear. So it will randomly pick, let's say I have value, it will randomly pick 2 rows from anywhere in the data set, and then it will put into the train and test data set, because we are ultimately getting those two data sets. Okay, now let me move on. So we have done test split, and we have splitted the data, and now let me just move on to the next point, which is very important, that I want to fit this sample data into the simple I want to fit this particular model to the training data. I got the training data now. So let me just also import from sklearn dot linear model. This is where we were using earlier linear model, import linear regression, right? See, I got this. So a lot of things, as I said, the library does, the system does for us. We have to just use it, and this is the machine or the regressor we want to just create now, right? So that this machine will learn from the data, that is x train and x y train. Okay, so it is just an object I'm creating. I hope this is clear how to create an object. So we have seen in oops, and now I got this regressor, and I want to fit it for the training data set. Now let me just do this here. I will write all these things together so that it is easy to copy. And let me just do this regressor dot fit. Okay, fit is a function. You can just look at this, the help page of it, and then you will see what is this. Train underscore x is the training data, that is independent variable, and test underscore y is the uh, no, not testing. I don't want to test, right? I want to train using dependent and independent variables. So train underscore y. Okay, so this is the data. So these are the two values I want our machine to learn from, and uh, uh, provide some relationship or the correlation between x train and y train. Okay, let me just see what is wrong. I have train x and train y. Regressor fit train x and train y. So let me just run at this moment here. I can see this works. Now I am trying to fit the model. Regressor.fit x comma y, and the sample weight is not required. So x comma y, this is what I'm trying to give, right? Train x comma train y. So it is giving me error. Is there anything I have missed? Can someone figure out? Ensure then feature expected to the array. Okay, I got it. So let me just try it out, guys. Here, this is x, and and this is y. Okay. So this works on NumPy, so where this x and y data sets required to be arrays, right? We spoke this, but we just forgot. I assumed that this was giving us the NumPy array. I will just repeat this again. So let me just write all these commands together here. This I'll keep for our record later on. This is again something we can just keep here. Now this is where we are splitting this, and let me just do this. I just want everyone to be visible in a single screen so that you guys will relate it how the whole things are working here, right? So that's it. So we have this model now. Okay, it's in the single screen. You guys can see this, right? And I see that the regressor is the model now, which is fit for our training data set, and this machine is now getting trained or learning on the training data set. Okay, so now if we got a model, now we got to see that if whether this particular model does the right thing or not. Okay, that is important now. So we have to see how our model is working. So have you seen that this three lines here at this cell number 49? So what is this? This is where we are creating a simple linear regression, and we fit this particular regressor, this particular machine to learn from the training data set. Okay, so Shekhar is asking, there was some error, and we have fixed. What did we do for that? Anybody understand what did I do for fixing those errors? There was one error, right? So that error was saying that we have given a wrong data set. So trainx was a uh, pandas library, pandas object data frame, but it actually expects the NumPy based array in this regressor and fit. Okay, in this fit function, if you look at this, this x and y are the NumPy arrays. Look at this. Okay, and it has to be a matrix of some shape. Okay, and this y also. But earlier, by doing this, we are getting only a data set in the x, data frame in the x, right? And same for y. So we don't want that. We want to get that values from our data set, but that should be in the NumPy format. So this x is now NumPy. Here, if you look at this, print type x. So again, some hands-on is required. See, this is a NumPy array, and now that error has gone. Okay, so anyway, a little bit more hands-on will make you comfortable with this, and we see that the regressor, the model has been created. I repeat again, the model has been created, the first model, and we have fit that model into for a training data to learn from that training data. Now this is a machine this is a machine now, regressor, which is learning from train x and train y data. Okay, but what to do if machine has learned already, and I want to validate, I want to check how to see that, how these things happen, and I want to probably predict. So suppose I want to predict y variable from this model, that is regressor, and I can use this predict function, and I can predict using let's say x test x. Okay, so test x is a data, and I want to see, let me just see here, y predict, and I'll see that there is a numpy array we got. So meaning is I want to see all the values here which are predicted for which data, for test x data. So these are the values. See, 1.5 1.3 years experience. So he is saying that, our model is saying that he should get the salary of 36,000 and 74. So let me just go back to our Excel sheet. So I'll just make it little smaller so that I can just show you in the same screen. Okay, so now look at this. So 1.3, the salary is 46,000, but our model is giving 36,000. Not good, not good predictions, right? For 1.1 it is 34,000, for 1.1 it is 39. Not so bad, it is little near to it, right? Now 4.5, this is the data which is test data, we have splitted, right? If you guys recall, so some part of it, right, this image, not literally meaning this data, but I know those many samples from this whole records. Okay, so for 4.5 years, our model is saying that the person should have 66,516, but the reality is, where is 4.5 salary? Here, the reality, the actual salary is 61,000. So we are predicting, we are near to the results, but we are not much accurate. Okay, so what, how to see that, right? So now let's understand. Test X is the training data, and okay, let me just go here. Ypred is the predictions, and test Y is the real data. Okay, test Y real data, test Y we haven't used any time till now, right? And test Y is something which is already there, and I want to predict, I want to compare with the predictions now, right? So this is the actual data and this is the predicted data. So comparison, 46 36, not much good. 34 39, not bad. This is also little closer, good. This is a very good prediction, I would say, right? It is saying that for fourth record, it is saying that we have, the actual value is 57,189, and our model has predicted that the salary should be 58,905. So it is good, near to the better prediction. So 98 and 91, so 80,000, 80,785 and 93, again not bad. See, 101 and 113, so this is again a little more difference, but better. So 55, 60, 42, 43. Yeah, this is again much better prediction, I would say, right? This is also better prediction. So now we can see that now we will decide whether to go or not, because this is important for us to understand that how our model is working. Okay, let me just do this a bit here. We haven't seen scatter plot, but now this is a good place where we can also learn scatter plot, which was part of our initial couple of sessions in data visualization matplotlib. So it was not a big deal, it is a very simple thing, but I thought that time we were running out of time. So here we can simply use it, and we can also see how this scatter plot shows about our data, right? So the train x, train independent variable, and uh, the dependent variable, right, train y. So I want to see this, just I will give some color here, maybe I'll give red, and let us see what happens. Okay, this is how our train x and y looks like, and let me just plot this here, plt dot plot x, train x, comma. Now I want to get the regressor object to predict for train X. So what is it is going to predict, right? I'll just use some other color here, maybe blue also. Okay, this regressor or this blue line is a, what is that? A blue line is the predictions what we are making for train X dataset, and these red lines are the actual data. Okay, so this is about the real values. The red points is the real values. Let me just write here, red points, data points, right? Points are real values, and the blue line is predicted values, right? So this is how we can write our simple linear regression model to see how this model is working, how this behaves, and then we can we see that how our model is working for any new data that might come for predicting some values. Okay, so let me also see if we can do something for calculating the mean square error. We have understood, right? There's some mean square error. So this is the gap between the blue line and your red spot. Blue line and red spot, there are positive and negative. So we know that there is numpy. We can use mean for y data. So test data, we will just go with test y minus y predicted value. Okay, and we want to square it here, and then it will let me just check. No, I think something is wrong. Test y minus predictions numpy mean. So this value should be somewhere below 100 for sure. It's not that big. Or we can do this instead of doing manually. I can think about scikit-learn library for doing the same thing. Okay, sklearn dot metrics. Let me just see if I can try to find this mean squared. Okay, mean squared error is there. No, I don't know how to use it, but let me just try it. Mean squared error. We have test y comma y predicted values, correct? Oh, okay, it is giving really a huge number, and might be that is the reality. So let me just go back and revisit our model. So here 1/3 of data we are trying. Let me just try it 20% data, 0.2. Okay, and I will give random state as 2, 3, 4 or anything. Okay, these two things we change now, and let us see how this works. Now you see the samples here. Earlier this was different, and now this is 24 and 6. Okay, I go there, I create this regressor, I predict now, I have predictions now, and I have these values. So this predictions looks little better probably. 67, 72, 56, 53, 101, 100, and yeah, this is closer now, right? 116, 115. So these are better predictions, it looks like. Since it's a small data, we can just try it here. Yeah, so now there are more data points we are trying here, and let me just run this here once again and see if my mean square error is less. Okay, this is really huge. This is like 14 million, and this was 60 million, right? A lot has been changed. Now this is becoming a smaller one. So I don't know, but this is not some practical number. This is data is not a practical data, in fact, right? So this is just for our learning purpose. So important is before this plotting before plot, you guys should understand and hold on for mean squared error. I will come back and do something with the next example which we are going to do today, right? So this is how we have developed a very first machine learning model which will learn from the machine, and then it can predict the values for our data, right? And we are testing it for our data, that is this test y, and these are the predictions which is actually the new values which our model has given. This is nowhere these values present in our data set. So these are the new values. Model is telling that for this where is that test, yeah, predicted. So for the experiences against these values, in fact, let me just write down here, it is test x. Okay, so yeah, in fact, for these experience levels, so these are the predictions it has given, and these are the actual data which is already present in our data set. Okay, is there any question, guys? I give a pause, I will unmute you guys if you want to speak. I will unmute you if you have something to speak, but I just want to understand how is your learning understanding about this model. The very first model, the machine learning model we have developed, it's end to end, right from our data pre-processing. Good part is we have not required to do so much with the data processing. The reason is our data is very structured and very well data we got. There is no missing values, missing data, there is no categorical data. There's lot many things are simplified. The idea was not to play with that, the idea was to build a model. So that was a simple data I used here to predict some of the values for different experiences. Yes, anybody has any question, anything you guys want? Chirag is saying this looks good. Can we do one more example today for more exposure? Yes, Chirag, that's what I said, right? I will go to one more example with one with missing values. So why you want to go with missing values? You have already experienced that, right? Using pandas. Yeah, we will do sometime for sure, but we will go with some built-in data set. So we may not see some missing values. So I don't want to confuse or overload with lot many things here, right? So missing values, so that we have already done separately, and we will do this say going forward for some other models. But here idea is to just go through train test split, how we are splitting, how we are using the data, how we are writing a model, how our model is getting trained using those splitted train sets, and how your model is predicting using your test data. Vinay saying, sir, I'm getting same error as on line number. On line number, what line number? Sir, I'm getting same error. Okay, the fit line, right? Okay. Can we do validation? Yes, Mukesh, validation is what I was trying to do using mean squared error. So we will do validate this for the next example. But we have, since it's a very small data, we have validated here, isn't it? See, look at this, line number 69 is predicted and line number 73 is the actual value. So we can just validate looking at this, and also, so how we got this predictions is using the test set only, right? So now you provide any set here like test underscore x, so it will predict. So we have already validated at line number 68 and 69. Mukesh, is that fine? Is that the validation you were talking about? Okay, so you mean about the equation. So we have the equation, and this equation we want to just put these values and try it. Okay, great. So can you try, or somebody can help me to write this out? So now we are pretty clear what all values we have, what all the predictions, what are the values for all these variables. Now he is asking if we can do something like this: salary equal to B0 plus B1 into experience. Now let me just show you here. Let me just print out these two things, ypred, y test y and test x. Let us do that here. Here y predict, then test x, and test y. What is test y? Test y is these are the actual values in our data set for these years. Okay, now you guys tell me, I want to do this here. Okay, so I want to predict I want to get the salary for, let's say I want to see a B0 value here. So first is salary. Let's say salary, I just give the predicted salary here. This value is already there. Now B0 is something we have to get. B1 is something again our model will give. So this way we can just put here, what we can put is experience. So what is the experience here? 4.9. Okay, this is the expression, this is our expression, the original expression, and we wanted to see that. Okay, so the price is equal to, price is our value, right? And we want to get that using our data. Okay, our coefficient. Now let me just figure out how to get those values from our model, right, which we have already used. So let me just see regressor dot, there's a coefficient which gives you the value there, and regressor dot intercept, which we can see the intercept is given here. Okay, now let me just see the salary here, and let me see the coefficient. I can just use this plus, I can use this slope or the intercept into 4.9, and let me just see what it gives. Okay, it is giving me 137,000 something, right? So these are the two variables, coefficient and intercept, correct? So this is what we wanted. So coefficient is there and intercept is there, the model is giving this, and we have to just put those values. The intercept is giving me something. Yeah, I think that is right. Intercept is 26,000. Here the coefficient we find and the intercept is there. Have I done something wrong? Is this the formula right? Okay, we got these values now. Just let's print this first and then we will jump onto this later on. Coefficient and intercept. I just got these values from our model. So not stop, full stop, it's comma, right? Okay. So we got this coefficient. It's a list of the numbers, but it is, there is only one, so only one variable is there, so only one we got. Right. So what is the other outcome you are expecting, Mukesh, about this equation, the values? So these are the values we got. We fit the model, so we have to just validate the values here. But strange, I don't see salary equal to matching this experience and B1 B0 plus B1. So maybe the values are getting different. So coefficient is really huge value. It should not be that, I think. No, it is correct, right? It was in our this line here, it was near to 10,000, isn't it? So this is the value we got, 9,418. That is the exact value we got, and intercept is 26,000. So strange, this is really huge number, right? So every year 27,000 is what is 26,000 is what is we getting increased. Yes, Mukesh, just hold on for some time. We will think about how can we reduce some errors, right? One way we have already seen here, if you realize this, is by reducing by providing more data, your model will do better, and that is the way to do. So surely, our data is not really good data here. We have a very small data, and with that, the predictions are quite straightforward here, and there is some error. There is no doubt there is error. So it can be more accurate going forward with different algorithms. So this is a very basic algorithm. One should really know it, but practically it is very less used. There are much better algorithms which will predict much better values than it looks like very near to the real values. So the idea here today's session is to get familiar with all these terms, all how to split, how to train the model, how to validate the results. Okay. Anything else, Rakesh? How can we decide on sample size? See, the thumb rule, I think yesterday also I talked about. So if we have huge data, and definitely, usually like at least 80% should go for training your model. More data you provide as a training to the model, so your model becomes better. Okay. So if you have a huge data or whatever data around 80%, 90%, 60%, 65%, it's up to you what you want to give. It depends on the business or your data. So if you have the data, you can decide how predictions or accurate data you want to give. So is that what you wanted to ask, Rakesh? Okay, should I unmute for a couple of minutes if you want to speak something? Yeah, yeah, I have unmuted. If you guys want to speak something, feel free to say it. If somebody is speaking, you have to unmute yourself also, in case if you are self-muted. Okay, great. It seems, yeah, anybody is speaking?
Yeah, Sachin, this side. I was wondering, in case, am I now? Hello?
Hello,
Am I
guys.
audible?
Yeah, whoever is not speaking, can you mute? Let me mute everyone, and I will unmute only Sachin. Let him say, let him finish, and then we can talk further. Yes, Sachin. Now you can.
Okay. Actually, I was trying to understand that how the regressor can help me if I want to use data, or I want to have a prediction for some range which is not in our data set, like for 30, 40 years from now. Can it help in that way?
Yes, absolutely. So this is a
Actually,
simple question.
yeah,
Yeah.
let me. Yeah, actually, sorry to interrupt you again. Actually, the question is because I'm trying to map a test data for one of my project which I'm going to represent in my company, and wherein I would be using Python and regression, or I think regression will help me there. So,
Okay. Great.
yeah.
Great.
Maybe
So
after the call or someday again, I may be connecting with you on this.
yes, yes, sure, no problem. So we can do that, but that is the obvious question that what Sachin is thinking is, okay, very good. We have a regressor, we got a machine which is learning from a training data and which has produced output on our test data as well, right? But how we can use this for the real data? Suppose I have some salary or some experience range, let's say 2.5, one person joined with 2.5 years experience, one person joined with 7.9, one person joined with 17 years, one person joined with 19 years, right? So suppose this data is not available in our data set. Okay, and that is pretty obvious, right? Here you see, so your data, there is no experience beyond 10 years here, right? 10.5 years. Okay, now our model should predict even for 17 years, salary might go to up to 200,000, right? But whatever salary, so by looking at this, obviously it looks like salary should go up. Maybe our intelligence is saying that it might go up to 180 or 190. So but what our model gives, okay, that is the question, and we want to see if this is possible to use this regressor to get this predictions. Okay, so absolutely it is possible, because that is the purpose we have written this model to work for. So anybody can help me to get this answer here? Anybody who understand this? If they understand, it should be straightforward. Probably you guys should be able to do it. So yes, can anybody give a shot here? Try here. What did we do here? Yes, yes. Yeah, who is anyone trying to speak? Okay, so nobody understand what to do. What is the complex part of this whole model, whatever we have written? Is there anything you guys see still this is complicated thing? Is there anyone who understands the best here out of this whole things? Yes, Shekhar is saying that we have to substitute the value of x to predict y, but for how long we can predict, I'm not sure. Mayank is saying model is clear, but equation result is not matching. Yes, Mayank. So we have seen that the coefficient is right, intercept is right, but somehow this equation, I will come back to you on this. So up to this point it was good, but even the mean square error is not good. I don't see that is the right value. So maybe if something is wrong, I will come back to you guys later on. So what has made this wrong? I'm using right data. I'm using, there's no mistake in the data. So I don't know, right? So I'll come to this part. But you understand the model. That is good part, Mayank. Okay, great. And Shekhar is saying that we have to, okay, Mayank, can you give a shot here to understand how to get the predictions for this data? This data, suppose this is the data. So as Shekhar is saying rightly, he pointed here. So now suppose if I give this, so ypred is predicting the values, right? For which data? For test x. Okay, this is the data and this is what it is predicted. Now it is all about getting this into this numpy array. Now new data equal to dot array, here 2.5 comma 7.9 comma 19 17 comma 19, right? Let's try this and see if this might help us to get something here. So this is a similar data we got here. And now let me just try to predict new pred. So if we don't get the good results, so we have to just at least revisit back and understand uh, new pred. So these are the predictions. Now let me just see how this looks like. Okay, see, look at this. The model is doing what it is doing is for 2.5 years of experience. So we don't have value 2.5, but 2.5 person is getting salary around 49,000. Okay, and 744. So I don't know, is it a good or bad, but it is something, at least has not given something like less than 30,000 or maybe in more than 100,000 or something, right? So definitely our model is not so accurate, but it is working as expected, right? The second thing is 7.9 years. So it is almost, oh, 7.9 is already value was there. It was 101, but our model is saying this is the value. Okay, so we are near to the actual data what we have, right? I thought this one 7.9 is a new value, but anyway, it worked for that also. Now there is a 17-year experience person. So for 17 years, this data is our model is saying that he should have this salary. And our intelligence also, we were guessing that okay, his salary should be somewhere in that range, isn't it? For 18 years, every year the salary is getting increased. So 205,000 and 150. So this is a salary. So is that what you were talking? Who asked this question? Mukesh, you asked this? No. Who was asking this question? Yeah, Rakesh, right? How decide on the sample size? No. Okay, Sachin asked. Okay, yes. So Sunil, is this clear? Sachin, is this clear? And how about Mayank, Shekhar, so Vivek, everyone? Do you guys follow this? Okay, great. Okay, great, guys. So perfect. So do you guys want 5 minutes break? We won't take it 10 minutes now. We will wind up a little early. So let's take a quick 5 minutes break, and then we will resume, right? It is 103, sorry, 10:03. So we'll be back at 10:08 sharp, and we will continue the next topic, next thing. Okay. Okay, I'm back, guys. So just let's wait for 1 minute, those who are probably joining. Yes, meantime, is there anyone who want to say something or any question? Okay, Chirag is back. I hope other people are also back. Just 1 minute and then we'll start. In that time, we can talk if there is anything. Yes, Chetana, please go ahead with your question. She has some question. You want to speak? I can unmute you. Just a moment. Yeah, if you want to speak, I have already unmuted. Now you have to self-unmute.
Hi.
Yes, yes, Chetan.
Yeah, Ganesh, quick question. Earlier, when we created this model first time, you said this prediction is not accurate. There is a very major difference between the salaries, right? And
Mhm.
later you changed the ratio.
Correct.
That's first we took 1/3, then you make it 20%.
Yes.
So
So
this is a way
that was
to
no,
judge
that
the model.
see, in machine learning, mostly what we do is, many times we try different things. Okay, we do generate, we do provide, like earlier I have given less data, and now I am giving more data to be trained. So, and if you give more and more and more and more data, right, your model becomes towards the perfection, right? But that is not the only way. But if you have multiple variables, we have to really work with many other factors as well. But in this particular example, we have just reduced the test size so that your data provided to the model is more, and that might help to predict in a better way. Now look at this. If I say that 2.2 person will have 39,000, 2.9 have 56, and if I give 2.4, 2.5, 2.6, and if I give some numbers here, so now next time if we get, if I get 2. Let's say 5, so there is a chances that it will predict to the closer value which is there, right? Otherwise it is now, see, 49,000 for 2.5 is like somewhere in between these two, right? Kind of an average, or average of these two, or maybe in between the half of this thing, right? But if the model knows that 2.2 to 2.8 mostly salary lies around 45,000, then your model probably would have printed given 45,000, right? But it has given 49. So that is how we can tune our output, and we can test different things to make your model better. Okay, this is a very small data, so sometimes we don't get everything. So this is for the learning purpose. Okay, now we will go with some more data, and that's where we will get little bit more understanding about your data, your model. Is
Yes,
that you? Yeah.
yeah, yeah, I got it. I actually my background is I'm from auditing company, and basically we received a lot of data and with lot of columns, and
Mhm.
sometimes we have almost 150 columns. So it's how I can predict that what column we can pick and how we can fit the best model. Is any tip on this?
Yeah, we will do this, give a couple of more weeks. So what we are doing now is we are just, baby steps we are taking. This is the very first model we tried to write today, and very few, practice hands-on we did on the data. So let us go and do some more deep dive on the various data sets and a couple of more models. So that time you will realize that, okay, these are the some of the aspects that might help you. But of course, bottom line is you need to learn your business, your data on your own first. You have to understand what all features of that data are important. Feature meaning the independent variables. So we need to understand that, right? Probably in our next example we will do a little bit of that sort, but just hold on for a few more sessions. So after that, it's a good idea to talk about your individual data sets, and that will give a little bit more understanding. Okay. Okay, Chetna is good with this. Now, is there any question? So let me just move on. Even if you have question, keep on typing. I want to take you through one more data set now quickly. I will do this sklearn. Do you remember we have some data sets in sklearn as well, and we have used it. Let's say load Boston, yeah, load breast cancer, diabetes patients, digits, and iris data set. So these are some of the data sets which are commonly used, kind of a real data set for the study purpose. We can just use that, and probably I will just write get that data set loaded here, load Boston, and I get this, let's say I just use BOS or something for creating the data frame out of this Boston data, right? Boston dot data. Now let me just see what is there in the Boston Bose data set. Perfect. So we can see a lot many things here, but there is no header, so it is not a good idea to really work with this, because without knowing what is there, it's difficult. Okay, but there is everything provided by this this data set. Let's say I want to just get the columns from Boston, right? Boston dot, there is a feature set, sorry, there's a feature set, and these features are meaning these are the independent variables, or these are the features which this data carries. Okay, and we can get this information a little bit more about this details. I think in the last one of the session we did this a little bit there, right? So you can just revisit that and get little bit more information about it. So this is how we get this information now. Now if you look at this, if you see the description, it is more about getting the prices of the houses in the Boston area, and there are multiple parameters which affects the price, right? The crime rate in that area, then there are a lot of things here, the age, and the tax, a lot many things are there. Now we need to learn this data first. Yes, Gaurav, thank you. I think you guys are every time reminding me. I see that when it was 10%, so I thought I will put the charger when it goes to 5%. So yeah, anyway, I'll just give me 1 minute, guys. Okay, so yes, so we got this feature set, and there are some attributes, and definitely we need to learn this. Okay, without learning the data, it is really difficult. Since I have practiced couple of times, or maybe many times, on this particular data set for a couple of years, so it's like I know a few things here, and we can directly jump on to understanding this data. But mostly when you deal with your real problems, or your office or your work, whatever you do, so if you get some data, so learning your data is important. Understanding your data, what you want to predict, so which algo to fit where, right? And anyway, that is too early to talk about now. Maybe after few sessions you will get that kind of understanding a little bit. Step by step we will increase that maturity to deal with the data, right? But here the basic focus, the first focus is to learn your data. Now Boston dot prices. Okay, price or prices, let me just see, price, I think. Okay, let me, oh no, Boston target, it doesn't know what is the target here. Yeah, so these are the target, this is a target variable, so it has a huge data. In fact, this whole Boston data set is a huge data, and we see that there are some prices here, right? And all these prices is our target variable. So what we can do is we can just have our target variable added to our Boston data set. BOS is your data set, right? Your now the new data set where prices has been added, right? We know how to add these prices. So that's why I asked in last session. I have given one assignment. So that is really important for you guys to do some hands-on. That will give you how to play with your data. Okay, pandas is really important to know, and that will help you to do such small things in your work. Okay, so now why this target variable I'm adding to my data frame is because the target variable is nothing but the value which I want to predict, or the dependent variable out of this all data set, and rest all are independent variables, right? And that's why we need to have this price here. So we have now we got one data set that is BOS, and this BOS is having whole this all this data. Okay, now what I want is let's say I want to create X and Y. Now what is your X here? Can somebody quickly say what would be X out of this? Now ignore everything before line number 99. So now line number 99 is what you have, and now you have to just think about it. Before line number 99, ignore everything. Now at line number 99 you got to know that okay, this is your data, and now you want to write a simple linear regression. It is not a simple linear regression, by the way. We have multiple variables, multiple independent variables, so it becomes a multiple linear regression. But even a multiple linear regression is a simple linear regression. The library does the same thing with multiple data. Now our focus is on simple linear regression. So let's not get complicated, make things complicated. So with the same understanding, so what do you think? What could be your dependent variable? Let's say if you can't find out X, how can you find out Y then? Y is a dependent variable. I write here. Yes. Let me increase the font. Yeah. I got one answer from Chetana. X equal to price. So, sorry, Y equal to price. That's right. Y equal to price is the right answer here. How to get that price here? Constant dot price, and I got this Y. Okay, Y dot head, and I can probably see the prices here. Now the X value is the dependent variable, and she says X is age. Chetana says X is age. Rajshekhar also saying X is age. But why only age? Why not crime rate? Why not something else? So it is just maybe you are just thinking that as age grows the prices grows, or I don't know what you thought about. But for me, what I understand out of this data is X, if target is a price, or Y is a price, or dependent variable is a price, so rest of the data is the variables, the independent variables. Those are not dependent on anything, right? The price is depends on all of this. So what we can do is we can take whole data set as the X value except price. So I don't want price to be a part of X. So what we can do is I can just drop the price column from this particular. I'm dropping a column, guys. Okay, so what I have to do is I have to use the axis here. And now let me just see X dot head. Let me just try it here. Yeah, I don't have price now. The reason I have dropped price is because price is now a different data, that is a variable data, variable independent variables, sorry, dependent variables. So I just wanted independent variables into X. So except file, except price, everything was independent variable. So I just wanted to put that into X. Now I got X and I got Y. Okay. I got X and I got Y. I can see X dot head, and I can see Y dot head, and this is how I got one our data set now. Now we have already seen there is a linear regression, so I can just create a regressor here, or I can just use any name, right? This is just a name, LM, or maybe you can try with something else. Now linear regression we already have imported some time back, so I don't have to go to sklearn.linear model to import linear regression here, right? So we have already imported, so we can directly use LM or maybe regressor. You can just go with the regressor otherwise, right? Regressor equal to linear regression. Okay, this gives me this the regressor model or a machine what we are thinking or talking about, and I want to fit our training data, right? Or maybe we haven't split it, training and testing. So for now we can also try just to minimize the confusion, because this is a little bigger data set. Now what we can do is we can provide whole data as a training data. Is that fine? So let us not get complicated, or I can go and train or split that before this, right? But I can just try it with the whole data here for just simplicity. So let me just fit this data X and Y uh, into the model, right? And the whole data is fed to the model here, right, to create the regressor. Now let me see, there is no error, the whole data is fit. Now let me just see slope. We talked about slope of straight line. Oops, sorry, straight line, and is what is that, regressor dot coefficient, correct? And what else? Intercept. Intercept is intercept. Oops, sorry. Let me see. There is a slope for every element, every every uh, independent variable, correct? So that slope is the list of slope here. We got that, and intercept is the constant value, that is 36, which is constant even if you don't have anything, right? So now I was just trying to understand our mean square error. I don't know, we got some weird number. I will validate it whether it is right or wrong later on. But let me just see here how we can have this new data set which we can use for these two things. Okay, now we got these two things. So what we can do is, let me just think about this expression, y equal to b0 plus b1 into some any variable, right? Let's say I will just take crime here, right? CRIM, the first one. Okay, so we can just think about taking that first one. So our the intercept is this 1.07, that's negative, and that is in fact 0.107, I think, correct? So let me just do, and there is an intercept value as well, that is 36 provided. Now you can put here in this formula, and you can just get the value here, predictions. So just for, I'm not doing this calculation, but maybe you guys can do this. Now b1 is your 36.49 and into the crime, CRIM value, whatever value you have, and this is how you can predict the value from this linear model. Okay, so model has been created using this whole data, but let me just go and do our basic stuff once again. Y1 I will just do, and I will just comment it out here. So I'll share this notebook also later on. So let me just try the same things with our test and train test split. Okay, let me just do this. Head, this is without price, and y dot head, this is only price. Okay, So let me just do this. Train X, I'll just overwrite, or I will use, okay, I'll just go with the same name. It's okay. Train X, then test X, comma, train Y, comma, test Y equal to train test split functionality, and I want to feed this two data. The whole data I can provide, or let me just check this, just a moment. Boston.data is also having the same thing, right? Yeah, Boston.data is a NumPy which is having all these variables. So I can in fact use this Boston data for here. X is Boston data only, right? Boston data. Do you remember this parent data? Let me go back here. Yeah, this is the Boston data, isn't it? So this is nothing but your Boston data only, just that I have converted it to pandas, and instead of converting back to NumPy, I can use just Boston.data, which is the NumPy array. Correct? So I use this Boston data for the X train place, and where there is a target as well. So Boston dot target. So do you guys recall this? Why I'm using this and why I'm not using BOS dot or directly X? Because X is a data frame, and this function expects NumPy arrays. Okay, so this is the same thing we have. Test.size equal to 0.33 or 1 by 3, whatever you want to give, and let's say random state equal to 5. Okay, let me see if it works. Yeah, this is done. Now train X, we can see these values. In fact, I can do is dot shape. I can just see that, and I can also see here test X, right? So the test data is 167 rows and 13 columns, and train data is 339 rows and 13 columns. And for that matter, train Y dot shape, you can see that this is the only one column, so you don't find this 13, like 13 columns are there in the X data, that is independent variables, but dependent variable is single, and rows you will find is same number 339. And train no, not train, test underscore Y, oh sorry, dot shape, I don't want to print whole data. Yeah, and this is again 167. So it is like 1/3 data I have divided into train data set, and sorry, a test data set, and remaining 2/3 is part of our train data set. Okay, now let's create model regressor 2, regressor 2 dot, yeah, it is a good idea to use different, otherwise, because earlier I used regressor only, so that might be the reason sometimes few of the data might overwrite. Okay, anyway, that is different thing. Dot no equal to linear regression, which is already there, we have imported. Now regressor 2 dot, I want to fit this training data, and yeah, training data to the model here. Fit, the spelling is wrong. Yeah, so this is how we got a regressor now, and where this model is trained on train underscore X and train underscore Y. So this is the target variable, and these are the independent variables. So we got this model trained, and I might want to predict something. Let me see if I can do something here. Predictor, sorry, predict, and I will just do this with test data. Okay, now let me just write down how it looks like. No, it's a NumPy, right? It's a NumPy array. So y predict we can do, and we can see a lot here. But anyway, these values won't make sense unless we really know what we want to do, because we don't know the real values, and it's very difficult for this data set to go and find this 500 rows. Okay, here we need to understand, probably by using the MSE, that is mean squared error. We already talked about. Let me just try it now. Maybe I'll just try this manually. I don't know, last time it didn't work for that data. Test into test minus y predict. Y predict is the name I used, and to the power 2. Correct. So mean. Okay, I just want to give this here, the whole bracket, and the data is there. Yeah, this looks good. This is the number I was expecting. Again, this is not a good number. So your MSE should be, let me just write down this here for clarity. MSE mean squared error of the model is this. Okay, so what is wrong? Yeah, I have to write one more bracket. Okay, the mean squared error is, this time I got 28.54. So this is not really a good number. It should be really a smaller number. A 0 is the ideal one, and it's not possible to get 0. Zero ideal means there is no error. Every point lies on that blue line, right? Do you recall this blue line here? Yeah, so every data point, if it lies on blue line, that means there is 0 MSE. Right, there's no mean squared error, because we don't have to draw any distances between this line, blue line, or your red point, and get that squared to find out the error there. So there is some error, but it is 0 is ideal, and near to 0 or the smaller value is always better. And now let us try to understand little bit by doing your test split, whatever split we are doing here. So let me just try it out with some different values, that is 0.2, and random state we can just keep it, or maybe we can just do it 2, and we will see. Yeah, it has changed. 404 we are taking it part of training, and 102 as part of testing. Okay, I'm just running this. I'm just running regressor once again, and predictor once again, and just remember we had this value. I'll just save it for the reference. This is the old value, and now I run this. Now I got 18.51. So the mean square error getting changed by making your model to get trained by more data than what we have provided in our first example. Okay, so this is how we can just try to tune your model. We can if it is a high value, 28 is also high, and probably 18 is also high. So we can even work further, but we cannot give the 100% data. Even if I give 100% data, I might get MSC a little more better one, but there has to be some more data to validate whether these things are working or not. And we could do that validations using our test data, so we have to have some test data as well. So it should be closer to 0, and when it is high, meaning the model is not accurate to predict, right? So model is to make the more accuracy, we have to minimize that somehow, right? So dependent variable determine the MSE, and this is probably we'll talk a little bit more on multiple linear regression, going forward a little bit. Time we'll spend there, and then we will move on to linear the the other topics going forward. Okay, the logistic regression and all, right? So this is again important thing. Let me also do the same thing as MSC of the model, and I will also do the same thing using the built-in function. Not built-in function, but function from matrix, right? Do you recall this? Let me just Write down here once again. You saw that sklearn, sklearn dot metrics import mean squared error, right? And we can also use this instead of all this. This is anyway I internally must be doing the same mean squared error on test sorry, test y and y predict whatever predicted values we have. And let me just see if it gives me the same value. Yeah, it gives me the same value. This or this, both things are doing same thing. Okay, Veena got a very good value. So she's saying that she got 0.45 value. Okay, strange. You are using the same data set, right, Veena? On the same data set, on the same parameters, how it is possible to get that difference? There's a huge difference, right? So have you used, okay, probably then you must have given whole data as we did here initially, this place. We got this regressor here and we can probably predict. I did not predict here. I simply jump onto the train and test. Okay, all same, but she's getting different value. I don't think that is how come this is possible. I don't see any reason to have this much difference. Anybody else tried the same and got different values? So it is not dependent on anything else. So it is, you know, if I do the same thing any number of time or anywhere, this should give the same thing, right? There's no reason to get this different value for different systems. Okay, how about others? Is there any other question? We can spend 5 more minutes to talk about, you know, if there is any question which we need to talk, or is there anything which is unclear? This is a simple linear regression, the simplest one. And the important learning here is about some pre-processing stuff, getting your data, getting your you know, test and train data sets, splitting that data, and then creating a model. So most of the things are done by the system. Yeah, is there any question? Rakesh is saying, does Python have some library to check alpha value from sample? What does that mean, Rakesh? Alpha value means? I did not get that. Alpha means only the check where you want to just have a check that the values are alphabet as a string, is it, or what? Rakesh,
Could you hear
maybe
me? Yeah.
yeah, now I can.
Could you
Now
hear
I
me?
can. Yes, yes. Now I
Now,
can.
basically, when we get a sample, we check whether the what is the alpha value to check this consistency. If it is more than 5%, then we, reject it. So this type of thing. So is that in library or we need to do is manually then,
No, I
through
think we
model?
have to do it manually, but just
Okay.
hold on for some more time. There are, you know,
Okay.
similar checks can be done in different ways to validate
Okay.
your model with some you know, better validations. In fact, we can do it
Yeah.
later on. Okay,
Okay.
so
Thank you.
yeah, that time probably I'll explain you how to get that you know, to handle those such scenarios, right? To validate something,
Okay.
to think.
Yeah. Yeah. Okay.
Yeah, yeah. And there is other questions like where Chetana is saying where we use test data to check our model. So have you used test data here? See, look at line number 132. So we are now predicting From test data only, right, Chetna? So what was the question here? You got it? Now we have, okay, you got it. She's saying you got it now and it was missed. That's okay. Now the predictions are there. You have a test data. Now you can also compare these predictions with your test data, and you can test Y. Okay, test Y is the actual results, because actual output or actual target values which is already present in our data sets. Okay, and Y predict is a predicted values from your model, and those two things you can compare and find out mean squared error. That indicates that there is a variation, and we can probably understand that how accurate your model could be. Now Sachin is having one question. Can I have your contact number to discuss about my project offline today, or when you're free? I just want to. Okay, fine, Sachin. How should I proceed? Okay, fine. See, the WhatsApp group is getting created. I want to keep that specific to our discussions. So let's avoid the personal chats and other messages, and then we will take it. So may not be possible today, Sachin. As I said, I have to close the call even 10 minutes before our regular time. So maybe sometime later during the week, or maybe later on, we will talk surely. Okay, any other questions? Anybody else? So is everything clear 100% or nothing? Where are we now? How was the day? How was the session? Is it going good? Can you guys talk a little bit, couple of minutes we spend on the feedback? Is there anything I need to adjust, the speed or uh, anything?
Sachin here. I would like to comment that I don't know if you are going with the right pace, but I definitely need to work more so that I can understand it better. And I think it is because of the practice that I'm missing some of the things. But
Uh,
definitely, I got what you taught today, but I think it is because of the lack of practice that I'm lagging some things.
okay, okay.
So yeah, I got all those things what you have taught today, so there is no query on that. I just understand it in that this is all because of my practice, lack of practice actually.
Yeah, so that was I was saying, and this is for everyone that last week I gave some assignment, and before that there was Python sessions. So we spent good quality time on doing the basic stuff, the foundation I have been talking about, and that will definitely help you guys. So at least this week, don't compromise on the practice. So you have whole 5 days to do something, and I will share these notebooks. You guys have to type on your own on your systems, and then also you do some additional stuff there. I will share some data today, and one book also. One book is actually a bigger one. Size is huge, so I don't know how to share, but I'll do something for you guys. Now, Chetana is saying thanks, session is really good. Need some hands-on. Yes, Chetana, hands-on is important. Samrat, yes, it is good. Okay, thank you, Samrat. Gaurav, can you show with real-time data? Yes, Gaurav, let the people digest these things first. The messages, what we are giving, or the libraries what we are using. Let's get some hands-on with the libraries. Once we go with that, so we will jump on to real data. And don't you think Boston data is something for practice, of course, but this is like a real data only, and we have so many such real data provided in the market for learning purpose. So we can take any such data and we do, right? So it may not be possible to take some data which is specific to a domain, but we can take some general data which is kind of a real data. Session is good, Mayank is saying, and requires some hands-on. Yes, Chirag, need to practice. and grasp everything fully, but things like good for now, good, great. And Gaurav, we can relate with the real world. So just hold on for some more time. Let me go through a couple of more algorithms. Then you will understand that where to relate and what you can do in real life. Okay, Chirag looks good. Veena has shared her code, so maybe Vina, we can look at this in the next session. I want you to share once again. I'm running out of time today. Upload it to Google Drive and share the link. Chirag's suggestion is to upload the book, which is of your size. I can do that probably. Thanks. It is good session. Rishu, thank you. Yeah, Sachin also suggested. Okay, I'll think about that option of Google Drive. First ML model created, looks good. Yes, Rishu. Thank you guys, and we have done our first model. So it's long journey. Lot many things have to talk about, and over the time you will get things to relate with your real time problems. Okay. So thank you then. Have a great day ahead, and see you next week. So spend some time and practice. Rajsekhar, yeah, thank you. Okay, then I'll drop off for the day, guys. So bye bye for now, and see you next week, Saturday.